Okay. So, like I said last time, I wanted y'all to at least take a look at the review and see what kind of questions were on there. If y'all had any problems with them at all.
I have not had it.
Excuse me?
I'm going to be honest, I have not had the time to look at it yet.
But you've gotten it.
Yes.
Okay, that's the big thing. Okay. So, does anybody have anything that they'd like to go over before I just go into the entire review? Anything that's giving y'all trouble? Anything you want extra help with? Maybe another explanation? Number 3? So the one that I have for number 3 is the observational versus experimental. No? What do you have for number 3? Ah, GPA, okay. So this one's actually number 7 for me. It says calculate the GPA of a student with the following grades. So an A is for a 17-hour course, we got a B for an 11-hour course, a C for another 11-hour course, and then it gives us the grade breakouts for each of those letter grades. And then it wants us to round our answer to 2 decimal places. So, this is a weighted mean. We need to multiply our weight by our value. Okay?
I'm glad you asked that.
Excuse me?
I'm glad you asked that.
Okay. So, first things first, A, B, and C need to be converted into values. So, starting with A is a 4.0, B is a 3.0, C is a 2.0, D is a 1.0, and F is a 0. So for each of these, we need to multiply those values by the hours. So A times 17, A is a 4.0, so we do 4 times 17, and we get 68. Add the rest of these scores to it. So B is a 3.0, that's 33. 3.0 times 11 is 33. C is 2.0 times 11, that's 22. And then we will divide this by the available points. So 17, 11, and 11 are our available points. Okay, so let's go ahead and add these up. So on the top there we have 68 plus 33 plus 22, which gives us 123. Then on the bottom we have 17 plus 11 plus 11, and that gives us 39. So now divide 123 by 39, and we get 3.153846, so on and so forth. Remember, we want to round this to 2 decimal places though. So this will round to 3.15. Okay, does that make sense? So again, the big thing, make sure you multiply your weight by your value. So you got to get those values for the grades. So again, A is 4.0, B is 3.0, C is 2.0, and so on and so forth. And then we are taking the grades, or the grade points earned and dividing it by the available grade points. Any questions? None? Okay, what else would we like to go over? Okay, I'll just start in on the review as a whole. So, first one, determine the statement that describes a population or a sample, or determine whether the statement describes a population or a sample. Excuse me. The high school GPAs of all the employees at a textbook company. Okay, so would this be a population or a sample? Population. Why? What is the key word there? All. You see, all of the group, it's a population. If you're just taking a portion of the group, it'd be a sample. Good. Number two, in a blank experiment, neither the subject nor those conducting the experiment know whether the subject is in the control group or the treatment group. Is this a single blind or a double blind study? Double blind, yeah. No one knows what group they're in. Of course, a single blind would be where who knows what group they're in? Which person would know?
People conducting the experiment.
Yeah, those conducting the experiment would know, or the researchers would know. Okay? 3. Determine whether an observational or experimental study is appropriate to address the following statement. So, a general manager of a restaurant wants to find out her average daily receipts. Would this be observational or experimental? Observational, yeah. All she's doing is she's collecting those receipts and getting the data from them. She's not affecting any kind of change on the environment or change on the experiment. So it's just purely observational. Okay. A physics instructor wants to determine if taking a calculus course before taking his physics course improves students' grades in the physics course. The average class grade would be considered the what? Explanatory variable or response variable? Is what? Response variable, yeah. It's a direct response to taking the calculus class. Remember that an explanatory variable is something that could explain. It is the driving force behind a phenomena. But a response is just a simple response to a stimuli or change. Okay. Number 5. Yeah, this one's kind of cut off. Here's the rest of it. A mid-sized mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percent of the complaints are due to the category incorrect billing? Round your answer to 2 decimal places if necessary. Okay. So we've got a frequency table here, and we want to know what percent of these frequencies is incorrect billing. This category right here. So what we want to do is we want to basically take this as a part out of a whole and convert it to a percent. So that's going to need to be a proportion. So again, like I was saying, this is a part of the entire thing. It's a part out of the whole thing. So this is 89 out of well, the total, so we got to find that total. So we've got 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156. And that gives us 790. Okay? So this should be equivalent to some percent out of 100. But we've got to convert it to that percent. So the easiest way to deal with a proportion is to cross multiply. So multiply the numbers that are across from each other. That'll give us 8,900. And then divide by the number that's left over, 790. So 8,900 divided by 790 is 11.265822, so on and so forth. We went around to 2 decimal places, so that's going to be 11.27. Someone in previous class, and I do want to point this out, said, well, can't we just divide 89 by 790? Yes, you can. If you divide 89 by 790, that will give you a decimal representation of this ratio. We then need to take that decimal and convert it into a percent. So 89 divided by 790 will give us 0.1126. So it's off on the decimal. It's because this is a decimal representation of a percent. To go from a decimal to a percent, we move that decimal twice to the right to make it 11.27. And I'm sure, as you know already, there are many different ways to solve problems in math. There's not one that's better than any of the others. Okay, any questions on this one? No, makes sense? Okay. Next, consider the following data. It gives us a set of data here. Determine the mean, the median, and the mode if there is a mode. Okay, so we need to order this data from least to greatest first. So we've got negative 14, negative 3, excuse me, 0. Let's see, then we have 3, 12, and 14. Okay. So first, we need to get the mean. So we need to add all these up and then divide by the n, or the number of data points we have. Let's see, well, lucky for us, a lot of these are negative and positive, so they cancel. So like negative 14 and positive 14 makes 0. Negative 3 and positive 3 makes 0. 0 is still 0. So the only thing that really gets us value here is 12. So if we add all these up, we get 12. Then divide by the number of data points we have, that's 6. 12 divided by 6 is 2. So there's our mean. Okay. Next, determine the median of the given data. So median is the middle number. And let's see, we have 2 in the middle here. We have 0 and 3, so we need to find the number directly between 0 and 3. So we can add those two. 0 plus 3 is 3. Divide by 2, that's 1.5. Okay. And now the mode, if there is a mode. So remember that the mode is the number that occurs the most. It has to occur more than the others. It has to occur more than once. Well, all of these occur exactly once, so there is no mode. Any questions? None? Okay, well, we just did the GPA one, so next page. So for the graph shown, determine which letter represents the mean, median, and the mode. Letters may be used more than once. Okay. So the one I would tell y'all to find first is the mode. Remember that the mode is the number that occurs the most, and on graphs like this, what we're looking at is frequency. So the higher the graph gets, the higher the frequency of that number. So here at this peak, this is the number with the highest frequency, or the mode. So that's A. Median is the middle number. It's what separates our data in halves. That's B. And then always on the other side of the median from the mode is the mean. So C. Any questions? No questions? All right. Next one, consider the following data. It gives us some data here, and then it wants us to do three things. One, calculate the sample variance. Two, calculate the sample standard deviation. And then three, calculate the range. I believe I took off variance from y'all's versions, and that's just because there isn't a whole lot of reason for y'all to use variance right now. Okay, and you'd be calculating it anyway when you calculate the standard deviation. So, remember that standard deviation for a sample, we're talking about a sample in this case, is S equals the square root of the sum of x minus x bar squared all over n minus 1. The formula for sample variance, just take that square root off and you have sample variance. So we calculate sample variance in the process of calculating standard deviation. Okay, so that's why I'm not that interested in that. I'm more interested in y'all being able to get standard deviation. But we'll go ahead and calculate it here. Okay, so the first thing we need is the mean, the x bar. Remember, x bar is mean for a sample. And it doesn't calculate any differently from mean for a population. It's just we need to make sure that we understand what we're talking about. That's why we call them different things. Okay? So we add up all these numbers. Let's see. -6 plus -4 plus -9 plus -4 plus -4 plus -9. And we get -36. Then divide by the number we have, so 6. So -36 divided by 6 is -6. So there's our mean. Now we need to do our x minus x bar. So again, what that means is we take each of these data points and subtract the mean. So -6 minus -6, think about that real quick. We have -6 minus -6. What's going to happen here? It's going to become plus. Good. So this is -6 plus 6. What does that come out to be? 0. Yeah. So these will still end up subtracting from each other in a roundabout way. Okay, let's see. So -6, take that away from -4. We should get 2, +2. This one we get -3, +2, +2, and -3. and then square all of these numbers. So x minus x bar squared, so we square all of these. 0, let's see, that's 4, 9, 4, 4, 9. And now we need to sum them. So, let's see, 4 plus 9 plus 4 plus 4 plus 9 is 21. And we need to divide that by n minus 1. So our n is 6, n minus 1 is 5. So divide this by 5. That's not what I got last time. I must have missed a number. Hold on. 4 plus 9. Huh?
30.
Yeah, I think I missed a number when I was putting this in. So 4 plus 9 plus 4 plus 4 plus 9. 30. Okay. Divide by 5, we get 6. Okay, so 6 is our variance. All you have to do to get to standard deviation now is take the square root. So take the square root of 6, and we get 2 point, well, rounded 1 decimal point, so 2.4. Okay, and then calculate the range. So -9 and -4 are our maximum number and minimum numbers. So what's the distance between 9 and 4? 5. Remember that range is a distance, so we have to calculate it as a positive or number that doesn't have a sign on it. That's what's called a absolute value. Okay, any questions? No questions? All right. Next. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that sales volume and advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars, so keep that in mind, they're in thousands of dollars. Okay? So the linear equation that it gives us is estimated sales volume equals 47.58 plus 0.55 times advertising expenditures. Okay, so if the company has a target sales volume of $300,000, how much should the sales manager allocate for advertising in the budget? Round your answer to the nearest dollar. Okay. So it gives us that we want to get $300,000 for our sales volume. And since this is apparently related to advertising expenditures through this model, we want to figure out how much we need to spend on advertising to get $300,000 in sales volume. So we need to plug in $300,000. Now remember, this is already in thousands of dollars. This is thousands of dollars, this is thousands of dollars. So when we plug in $300,000, we're not plugging in 300,000, we're plugging in 300 because this is already in thousands. Does that make sense? Okay. So this will be 300 equals 47.58 plus 0.555 times advertising expenditures, and I'm just going to call that A. Okay. So now it's just a matter of solving this thing. So we need to get A by itself. Well, right now, we're multiplying by 0.55 and adding 47.58. So let's get rid of these numbers. The easiest one to get rid of is the one that's adding. So we can subtract to cancel it. So positive 47.58, negative 47.58, cancel. But we need to remember that whatever we do to this side, we need to do to this side as well. This equation needs to be perfectly balanced at all times. Okay? So 300 minus 47.58 is going to give us 252.42. Write down the rest of this, 0.55 A. Okay, now we are multiplying 0.55 by A, so to get rid of it, we need to divide by 0.55. So that cancels out. Let's see what we get here. Divide by 0.55. And we get, let's see, 4, 5, 8, 9, 4, 5, 4, 5, 4, 5. Oops, forgot the decimal. 4, 5, 4. I think you can get the rest. Okay, it's repeating decimal. Now remember, this is in thousands of dollars, so is this. This is also in thousands of dollars. So we need to convert this to thousands of dollars and round to the nearest dollar. So to convert this back to thousands of dollars, we just move this decimal place 3 times to the right. So our answer is $458,945. Which does not look good for this company, by the way. Their advertising expenditure has to be greater than their sales volume to get that. So they are going to be losing money. Okay, any questions? Makes sense? Good. Well, that is the whole review, and this review is what I'm making the test from. So if you can do these questions, then you'll be fine on the test. Okay, so how do we feel about this? Pretty good? Feel like we're getting ready? Alright, so that review again is due the same day as the test. When is the test? Friday, yeah. So I want you to, I'd like for you to get the review done before you take the test. Okay? That way you'll be prepared for the test. Of course, I'm not going to be expecting it until around midnight. So that's the due time for the review, is get that review in before midnight on Friday. But I would really like to see y'all turn it in before you take the test on Friday. Okay? It's not necessary, but I'd like to see it. But I believe that will do it for today. I'll give you the rest of the day to just study and get that review done. So y'all have a good one.